If I had to ask you, see, we'll get them really fast. If I said the words EDM, ICS, super high energy, amazing hair, who would you think our next guest is?
You know, I could hear at least one or two of those things, and immediately Dean Parsons comes to mind.
Dean Parsons. And there's
There's
the
the
big hair
man.
guys, the legend himself. I love it. I love it, Dean. Welcome, welcome, welcome.
Thank you so much. Thank you so much. I'm actually super pumped to be here. First of all, for finally being on the forum. This is the third year it's happened. The third year's a charm, I guess, for me. Mandy, if you're out there, thank you for getting me on here. The time lined up very nicely. Thank you so much. Rich, Stacy, great to see you guys. Stacy, test your might. I'm going to go with Mortal Kombat.
You're the winner.
Yes,
You'll get
Mortal
your prize in
Kombat.
the mail. I'll email you later. Don't worry about it.
Fantastic, fantastic.
Do that offline.
Huge fan. Very cool. I've only been able to participate a little bit so far in the chat. I've seen some of these amazing presentation, fantastic content so far, lots of participation here. What I'm going to try to bring to the table today is looking at the control system side of the medical aspects, the pharmaceutical manufacturing of medicines and things like that. So yeah, I mean, I'm ready to go when you guys are. So I'm just happy to be on the show. Is that a cue for me to just jump right in here? I think it might be. Okay, cool. So welcome everyone. My content today is really focusing on the industrial control side, pharmaceuticals. Now, don't get me wrong here. There's a ton of amazing content out there, rightfully so. Protections required, mitigations required for field devices, medical devices, as we heard from V and other folks as well. From my perspective, what I try to bring to the table here is my experience in the field in industrial control environments, which include pharmaceutical manufacturing and so on and so on. So just a quick background on myself, as Rich and Stacy mentioned. My name is Dean Parsons. I'm a principal SANS instructor, and I teach two main industrial control system classes. Number one, a very technical hands-on class that's applicable to any control system environment, including healthcare, pharmaceuticals, et cetera. And we teach and we hack through 6 days of network visibility, detection, and response in industrial environments. So if you've wondered how medications are created and what the ramifications are if that is manipulated, that's what we're going to talk about today. I also teach and co-author a class called ICS 418. It's only a 2-day class for management. It's ICS Security Essentials for Managers. So long story short, author with a book, ICS Cybersecurity Field Manual out there, focusing on control systems, 20 years experience in the field. Telecommunications, power generation, transmission, distribution, oil and gas. You can read what's on the screen here, but I do assessments in the field regularly, technical assessments and risk assessments, talking with engineers at facilities, including pharmaceutical, chemical manufacturing facilities. So I understand the risk, and then I help tactical teams, engineering teams put in appropriate mitigations that are aligned, and I'm big on this, aligned based on the threats that we're seeing today. So the question really comes up, well, in an industrial environment, there's so many things we can do. So which one should we do today? What are the top 5 that are out there? So today I want to go over a number of things, a couple of statistics we've gathered that we do every single year in industrial control system spaces globally. Then I want to talk a little bit about what Stacy mentioned. Every one of these computer systems, devices that you can install Doom on, those are definitely computer systems. And we can look at those traditional operating systems, if you will, that can run Linux and Windows, and that's all wonderful. I'm also going to talk a little bit about the systems that are not traditional. In fact, 80% of a control system are running non-traditional operating systems, approximately. I want to talk a little bit about the differences between IT and ICS or OT from a manufacturing or chemical and pharmaceutical perspective, and then focus on those top 5 ICS critical controls we can deploy. Because we can deploy hundreds of controls, but again, what's the top 5 based on the threats that's out there? And what I'm going to do is I'm going to focus on briefing 5 of those and then really focusing on the top 2 with practical examples. See a lot of folks coming on here. This is really good. I know there's folks on from around the world. I've been seeing the comments as we roll through. I'm joining you from my home today. I'm home in Newfoundland, Canada. And yeah, pumped to be here. So let's get into the content. And we have a ton of content to go over. So let's speed up the pace just a little bit. So addressing IIoT and IoT. This is fantastic. There's tons of resources out there. This conversation is not going to focus on the large amount of excellent work that's already in the field on this, such as protecting field devices or medical devices with network segmentation, physically protecting them from firmware updates or malicious updates, encryption, strong authentication, data integrity checks, of course, and things aligned to compliance, industrial standards in the medical field, and so on. This is great. And there's a link there to kind of pivot to some of these additional resources for you. I'm going to pivot to the other side of that. Well, how do these devices, how are they manufactured? What about the chemicals and medicines that they use? How is that manufactured? Moreover, how could that be at risk today? And I want to answer the question, so has anybody ever tried to manipulate that process? And so the answer is coming up, but sort of a spoiler, then yes, there's capabilities out there. So the focus here is really inside the pharmaceutical facilities, going under the covers of the piping, the valves, the actuators, the sensors, the mixing vats, mixing up the different chemistries for medicines and vaccines and so on. So let's dive into this pharmaceutical factory and understand what's at risk and what's at play. Now, first of all, there is a difference between IT and ICS. And I just want to say we need to embrace those differences. I'm not saying don't do IT security. I'm saying, yeah, do it, continue doing it. But when we do industrial control or OT security, we need to kind of change the game a little bit because the risks are different. The controls are different. The impacts and, of course, the loss and consequences are different as well. So traditionally, we know that IT is focusing on data at rest, data in transit, and it focuses on that very well for decades. And that's excellent. Don't change it. Just continue to update it. On the ICS or OT side, we're really focusing on monitoring, managing, controlling real-time systems, not just like heartbeats and things and sensors inside a person's body. That's endpoint devices. I'm talking again, as you see in the image, manufacturing of what we rely on as medicine and whatnot. In that environments, real-time environments. Now, it just goes to show there's obviously different impacts. I'm not saying one is right or wrong or more important than the other. They work together in some cases, but we know that data being impacted is not a good day in the business side. Business applications being unavailable, email not flowing, not good. Data loss, ransomware, not good from an integrity perspective for the IT side and information that is digital. On the industrial control system side, we're really focusing now on the loss of a physical process or manipulation of the process. Now, the obvious manipulation could be, can you manipulate or can a nefarious person or group manipulate the mix of chemistry, changing what is then pushed into pills and liquid medicine, packaged and then produced and then distributed out into hospitals and so on. And I know there's checks in between, but let's get into a scenario you have coming up. So obviously there's potential loss of safety, loss of life in many cases when we're talking about industrial environments. So here is an example to just to look at it from a different perspective. Look at it from a perspective of where are those operating systems that we know and love and use traditional controls on that we all know off the top of our head. And where's the chemical manufacturing, the pharmaceutical generation, development, and creation of the medicines? So on screen above the red line, it's generally an IT environment. It might slightly differ, but generally above that line, it's a reference to something we call Purdue. But above that red line is where the IT systems are housed. Those are systems like email systems, communications, and file systems for the business and running the business and logistics. Great. Below the red line, that is what makes a pharmaceutical company an actual pharmaceutical company, the industrial control system. I don't want to bore you with all the details, but there's some devices in here like a programmable logic controller, remote terminal unit, sensors, actuators not running those traditional operating systems. And I'm thinking now to Stacy's question earlier, can we install Doom maybe on like a PLC? I'm not sure, but that would be a pretty cool project. Inside the control system, below that red line, that is what makes a pharmaceutical company an actual pharmaceutical company. In here, in this environment here, there's some traditional operating systems, but there's a lot of non-traditional operating systems. So what happens below that red line in the control system environment itself, the manufacturing process of medicine? It's manufacturing down there of what is called, in this case, in this sector, the active pharma ingredient. So the chemical reactions, the mixing, the heating. Of course, then there's also another engineering process, which is cooling the remains and crystallizing the sediment. Then, of course, there's additional filtering to reduce moisture, remove moisture to create the medicine, what they call dough. And then dough is then dried into a powder. We're not done yet. Still, there's engineering processes. Again, PLCs, controllers in here, using the vats and mixing the vats and then using conveyor belts at certain paces and rates to create what, of course, is now going to be the formulation and additional mixing in that process, drying that medication or medicine in many cases into dried grains. And then there's, of course, additional processes, which are going to be the tabulation, compression and shaping of the tablets. As an example, in this case with pills, of course, coating of the pills and so on and so on. And then, of course, we cannot forget huge focus on safety here, as in with all ICS environments. So control, quality control, sample checking, and so on. Huge factor, of course, because if something is manipulated, you see where I'm going with this as a spoiler, if it's manipulated, we need to double check to make sure that what is being produced before it gets labeled, shipped out, that is produced as expected. And that quality control and the equipment used there can then also be manipulated. So as we look at the IT side, above that red line and below the red line, everything inside of that red line below it, that's the control system. From the field, this is what we know. Contaminants or compromises into the control system from an IT environment happens very regularly. Nearly 40% of compromises to ICS environments threats come into the ICS from IT networks that are compromised, allowing the threats to pass into the ICS. So no surprise that one of the upcoming 5 critical controls is proper segmentation in the environment. So we're going to get into that, but this is an alarming number. So what about the controls inside of an ICS environment? Would we run encryption? Would we run endpoint? Would we run XEDR, et cetera? There's certain things we want to do because there's a nuanced way to use those common controls, and there's other ICS specific controls. One example of that is this, an incident response plan, which is another of the top 5 ICS critical controls. ICS specific incident response has to be ICS specific. An IT related incident response plan, as you see on screen, copied, pasted into the control system, can absolutely have ineffective and devastating results, which means we must have an ICS targeted, dedicated, related ICS plan. Now, if we take a look at the basic controls we've seen time and time again, which works great, don't change it for IT. You see under the IT column here, everything that we do and love today for the IT side above that red line before. Great. Inside the ICS on the right side, below that red line that we've seen earlier, there's a nuanced way to treat each of these controls. And in many cases, if they are not nuanced and not specific or ICS aware, they actually cause what you don't want. False positives, additional ramifications for safety, and so on. So deploying, I'll just say it outright, deploying IT controls inside of a control system environment can have devastating impacts and impede safety in many cases. So let's get into not the fear, uncertainty, and doubt, but let's get into, so what can we do about it? There's a paper written by Tim and Rob of SANS and the ICS team, and we support this and we use this, and I use this regularly in the field. I deploy these top 5 after you do assessments and so on. This top 5 ICS critical controls are based on the threats that are out there. So what we're going to do, we're going to pick 2 of them. We're going to now apply directly to pharmaceuticals and understand, are the plants at risk? Do we have these in place today? So the top 5 briefly are as follows. Number 1, as we kind of hinted at before, an ICS specific plan. Number 2, a defensible architecture to reduce that risk of 40% of compromises from IT down into the ICS. Proper, definitive, defensible architecture is needed for the control systems, protecting what matters most in the safety aspect. Number 3 here is the industrial control system, ICS specific or ICS protocol aware, visibility and monitoring. And the last 2, but not the least, of course, is the secure remote access, if and when it's needed by your engineers, your users, and your vendors as well. And the last is a risk-based vulnerability management. I'm going to tell you, each one of these is its own entire probably forum. They're massive, really easy to deploy. They are the ones to do first for various reasons, but I could go in depth on each one of these for like a day, but I'm not going to. So at this point, I'm going to do a little bit of a deep dive on the first one, ICS Incident Response Plan. Got to have a plan. It's no point having it like collecting dust. It has to be exercised, and it has to, in my opinion, professionally, be built on exercises that are realistic scenarios. And that's where we're headed. But we know this statistic as well, only 50%, roughly 52% of ICS facilities, including pharmaceuticals, including other types of sectors as well, just about half of them actually have an ICS specific plan. Why does it have to be specific? Back to that whole like idea of like Doom, the game being installed on traditional operating systems. Around 70 to 80% of a control system generally is not running traditional operating systems. So the detection capabilities, the controls to mitigate the response is not the same as IT. So has to be ICS specific. So number one, definitely want to determine for your ICS specific plan for your pharmaceutical factory, what is a bad day? What would pose the most risk that needs to be defended against? Is it ransomware? Is that really the highest risk today we should be targeted towards protecting against or defending against? I know it's impactful. Yes, don't discard it. Have it as a tabletop. But is it the most impactful one that's going to disrupt safety to customers taking medication, disrupting hospitals and supply chain? Let's get into it. Number two is that consider the consequence-based scenario. Ransomware, question mark. Next one is perform the actual tabletop. So here's one scenario. One scenario here is going to be, of course, the ransomware scenario. I want to push beyond this. Definitely do one of these, right? It's helpful to do this. Huge risk here, but continue on after this, right? Like every year, you're going to do ransomware again and again. You're going to learn from this 1 year, 2 years, and you're going to move on, be more mature. So do ransomware, which of course is taking out, unfortunately, common operating systems, shipping, billing, logistics could be impacted as well. But is the manipulation of the mix at risk? The engineering, the mixture of the chemicals and the medicines, the manufacturing. Generally, if traditional operating systems are not available, there is an engineering way to shut down things safely or continue in isolated mode, maybe limited capacity to save a batch, preserve a batch to make sure that it's safe quality-wise. So the focus should be on ransomware to start, but as you mature for your ICS protections, it really should shift and build on that learning into an ICS engineering specific attacks that we have seen. So enter pipe dream. Dun, dun, dun. Don't worry, we can detect this stuff. I promise you. Pipe dream is an ICS specific type of targeted malware that is scalable, right? Scalable meaning it can apply to pharmaceutical, it can apply to electric, it can apply to water, wastewater, etc. So here's the thing. Pipe dream is a great opportunity for pharmaceutical companies to model their ICS incident response tabletop after, because as you see here, we've done the analysis. It threatens the pharmaceutical sector because it has capabilities to impact medicine manufacturing, disrupting the production process, potentially compromising, underline this one, compromising quality control and safety mechanisms. Also, of course, when there's downtime and safety problems, potential loss of life in the field, as we know, et cetera, causing supply chain issues in addition to that, and so on. So this is a great tabletop to run. So here's the scenario we're going to suggest. So right now, if you've done the ransomware one, awesome. Hey, thank you so much for the comments. Really appreciate you joining in here. The scenario was this. Yes, the ransomware one, we passed it. The scenario is you have programmable logic controllers, PLCs that run your plant floor, determines how much should I put in this mix? How much of this chemical should I put in this mix? And what kind of coding should I have on it? All of these things are inside of logic controllers, rungs of code, how to do it time and time again. And if an adversary can manipulate that, that's what we're testing here without the use of exploitation, without the use of a vulnerability being present, which we have seen in many sectors. This is what you can test. And when you test this scenario, it drives ICS specific detections. It drives ICS specific, again, back to the 5 controls, network visibility, and it drives safety protocols. It'll actually test out your safety quality checks as well, whether they're manual or whether they're using automated equipment. It will test all of those things. And this will test a realistic scenario that we've seen time and time again. So pipe dream is not the first thing that we've seen in ICS that's scalable, that's impactful, but it is the most recent that is impactful to any sector generally, including pharmaceuticals. And I don't want to have anyone be sick or get killed as a result of this capability being available. And of course, the last but not least is it tests and drives the engineering system recovery. Here's where we're now entering into the part of the plant where when you do a recovery, there are engineering devices that require specific firmware information, receipt information, recipe data, configuration analysis, set point information for your PLCs, your human machine interfaces that our operators use to control the facility. Information about the configuration and system design for the smart valves that open up and understand how much of a chemical to put into a vat and how long to mix that for, and so on. So all of these configurations must be considered during an incident response. Who usually has this information? Not usually IT, because these devices are not traditional operating systems. But this, I promise you, is what runs your plant. So having engineering involved in this is a critical piece. The last but not least, I'm just going to focus on one more of the 5 controls, and I have about 10 minutes left, I think. Hopefully we're doing okay in time. Then I'm going to focus really now on this next piece, which is ICS network visibility and monitoring. What that means is, do we have a person? I'm sorry, ChatGPT is not going to help us on this today, but a person who understands how the manufacturing process works and how that is utilized. Can that be impacted today? Can that be seen today? Do we have people looking at the network? And if we do, an actual person who understands it, we're in the right spot. So let's take a look at what network visibility is. And it is today ranked #1 tool for any industrial control environment, including pharmaceutical, including the other sectors as well. And really what this means is looking at your network at a technical level. Now, if you're rushing to think, wait a second, we got this on IT. Let's do the same thing in the control system. An intrusion detection system from the IT inside the control system probably does not have the ICS protocol dissectors. I don't want to go too deep unless you guys want me to, but in general, it needs to understand the ICS protocols. And then we can pivot to where we're going to get detection. If today we get network visibility at the higher level up in the IT, what does that give us? It gives us all the usual things for ransomware. That's fantastic. And anything that could pivot in generally from IT into the ICS as an adversary commonly pivots from one network to the other. So level 5 for an IT, level 4 into the ICS, and level 3 into the ICS, and so on. So what I'm going to suggest is generally if you have visibility in level 3, which we're seeing here now, and below that in level 2 inside the control system, we're now looking at things like that exact realistic scenario we've seen earlier, manipulation of control commands, manipulation of PLC logic, changing the mixture of medicines and things of that nature can be detected at that lower level. In addition, going down even further, you can also detect things like combination of attacks, also denial of service access, direct access pass from OEM vendors, and so on and so forth, even supply chain as well. And of course, the next question is going to be, well, wait a second, Dean, this is a lot of things we can do here. Where do we start? Where do we get the right amount of data? How do we start that network visibility and monitoring the traffic? So here's what we've done. We've refined it down like this. If you're going to start network visibility, which you should, it's one of the top 5. It's the most highly sought after type of ICS tool today for control system defense and critical infrastructure. Then we recommend starting here. Focus first on the targeted assets, and simultaneously, those assets are the ones that are most critical to your pharmaceutical facilities. So between your human machine interfaces, where your operators control and understand the process, view the process, can start and stop the process, and the programmable logic controllers, where an engineer on the HMI says, do this thing. The PLC says, you look like the HMI. I'm going to go do this thing physically in the real world, open valves, open VACs, mix, etc. Between the HMI, the PLCs, you want to get packet captures there or visibility. Obviously, between HMIs and data historians, which are highly sought after in pharmaceuticals. Your historian is a targeted asset for two reasons. It's generally a very big, awesome database that stores everything about your medical manufacturing, including your manufacturing medicinal recipes. It's targeted because that is information that is highly sensitive and targeted for things like espionage and also, creating additional vaccines or medicines that are maybe beyond somebody else's capabilities. So it's highly sought after to improve maybe somebody else's manufacturing process. But also the engineering workstations, we call the EWS and the PLCs, and the EWS engineering workstation programs your PLC. So let's look at this basically before we go to the next section to clue off this session here for us. If the engineering workstation is accessed somehow remotely or through an OEM vendor or through supply chain, and it allows itself to communicate to the PLCs to reprogram the mix of your medicines, that communication is legitimate. That's going to be allowed. But if it's abused for nefarious purposes, no antivirus engine in the world will detect that stuff. So focusing on network visibility, pre-positioning of that type of attack is huge. And this is the kind of things that can save you from things like pipe dream and Indestroyer and a bunch of other types of ICS targeted attacks as well. So with like 3 minutes left, I think we're going to look at the takeaways, top takeaways. There is ICS targeted malware out there. It's not fear, uncertainty, and doubt and all doom and gloom, because everything I just showed you, having a plan that's ICS specific, testing it with a realistic scenario, and looking at the network to identify potential threats and how you could get compromised proactively before it happens is the right way to go. We know that the controls in IT is not going to be effective inside the control system specifically. They have to be nuanced and they have to generally be ICS aware. There's a ton of information out there on endpoint devices, healthcare devices in the fields and hospitals, IoT devices, IoT, and so on. This conversation has been really on the back end, the manufacturing piece. So to summarize, those two of the 5 controls, specific scenario for ICS threats that's out there, an ICS specific incident response plan that considers the engineering operating systems always, and the ability for the engineering operators to contribute largely to that recovery process. The teams that should be required there as well in the tabletop are going to be the ones manufacturing the medicines, understanding how the equipment works, repairing the equipment, etc. When we talk about network visibility, key takeaways here, it could seem like a daunting task. Go collect everything in the control system network. No, focus first on what's targeted, what we know is commonly targeted, the HMIs, PLCs, historians, engineering workstations. If you start off getting VLAN collections of just those conversations between those devices, you're in a very good spot. And this control of network visibility, if it's ICS specific, right, knows the ICS protocols, it yields you passively and safely an asset inventory. It also yields you passively and safely a vulnerability information and also ICS incident response capabilities and engineering troubleshooting capabilities. It's not just for security. So tons of value here. Really quick, ICS incident response, that's number 1 of the critical controls. Defensible architecture, number 2 for sure. Number 3 is what we just covered, network visibility. 4, got to have good remote access and perimeter protection to protect your ICS, 40% of which is compromised through IT. Generally, if IT is compromised, 5 is a key vulnerability management. Whew. We're just about done. Each one of these, as I mentioned, is like a full 4 in itself, but I definitely want to just hang here. I think I'm about on time, and I definitely appreciate everybody listening. So I'm going to cut it back over to our lovely folks. I'm sure Rich is out there and Stacy's out there at some place.
Absolutely. Dean, I got to say, every time you start talking, I think the room just goes silent and everybody just turns on like that super active listening mode, because it is constantly amazing information coming out the entire time.
Good stuff, man. That's good. I'm just hoping it's been helpful. And I know it's something that I'm very passionate about, and the ICS SANS team is very passionate about, because it's critical infrastructure, right? So a lot of value, hopefully, from this conversation for sure. Thanks so much for having me, guys.
Thank you. Hey, I'd like to point out someone did put in the chat the newer CISA advisories whenever it comes to ICS. So that's something that dropped, I think, this morning, a couple hours ago. So if y'all haven't seen it, there is a link in the chat to that. And, for me, I'm a policy wonk. I really like the flow of what we have going on today. We've had a ton of super excellent talks, ranging from about the medical devices to the controls of those devices. We've had a couple of jokes here and there about installing Doom on these things. And, as we mentioned, they are computers, but we do have to treat them differently. We do have to make sure that we, follow instructions like Dean said. And as another kind of added bonus, we also put in the chat, Dean has these field manuals for ICS and they're completely free. You can download them via the SANS website. And there's actually 3 volumes. So definitely look out for those.
No,
Yes,
absolutely.
absolutely. Oh, go ahead, Rich.
No, it's absolutely the Dean and the entire ICS curriculum are always putting out such great content. They're so passionate about it, and it just makes sense.